My name is Udh. I am a student of mechanical engineer. Those students are preparing for SSC JE, RRB JE, and different types of AE JE. This class is very important for those students because we all know that the previous year questions is very important for our game changing exams. Okay, this is the 16 number class. If you not watching my previous lectures, please go through the playlist and here you get the classes. Okay, if this class is helpful for you, please like and comment. Okay, let's start. Question number 376. A glass bottle filled with the liquid will break at the bottom if a stopper is forced into its O ends as the per. We all know that the in a bottle full of the liquid. Okay, if we stuck from the hair by our finger, then the bottle will break from the bottom because of this the Pascal's law. Okay, here the explanation. It states that a glass bottle completely filled with the water would be able to act as a hammer, meaning it could hit the screw and the bottle would not break. When the glass bottle is hit by its deforms applies the force to the water over some area and the Pascal's law, this same pressure is applied the everywhere throughout the glass bottle. Next question, friends. The depth of oil having the specific gravity 0.6 to produce a pressure of 3.6 bar. First, I convert this pressure 3.6 bar into 2 pascals. So 1 bar equal to 10 to the power 5 pascal. 3.6 into 10 to the power 5 pascals. Okay. Then we know that the pressure P equal to rho GH. There is the pressure 3.6 into 10 to the power 5 into rho g, and specific gravity 0.6. So density is 6, so 0.6 into 1000, so 600 into 9.81 into age. The answer is coming in meter, then you convert meter to centimeter. Okay, here the explanation easily given. 60 meter is coming, 60 meter is coming, but 60 meter is convert to the centimeter. Here is the option is wrong. 60 meter, then it convert into centimeter. 60 into 10 to the power 2 centimeter. Next question, friends. A 70 kg person walks on the snow with a total foot implant area of the 500 centimeter square. What is the pressure does he exert on the snow? We all know that the pressure equal to force per unit area. Force per unit area. There is a force to 70 kg equal to 70 into 9.81 is a gravitational force. So 70 into 9.81 divided by answer is Newton per meter square, and it is a Pascal. So first I will convert the 500 centimeter to 500 meter square. Then we know that 1 centimeter equal to 10 to the power minus 2 meters, so 10 to the minus 4, 500 into 10 to the minus 4, 500 into 10 to the minus 4. Then if you solve this equation, you can get the pressure. Let's check the answer. If the solve the equation, you get the 13.73 kilonewton per meter square or kilopascal. Friends, if it is this session is helpful for you, please one like for this session. Your like is motivate me to create another video. Next question, friends. Which one of the following option is based on Pascal's law? Hydraulic braking system. It's here use the Pascal's law. What is the atmospheric pressure, friends? We know the atmospheric pressure equal to 101325 Pascal, or if it divided by 10 to the power 6, then you can get the in bar. Sorry, 6 9 5 10 to the power 5, because one bar equal to 10 to the power 5 Pascal. 1 Pascal equal to 10 to the power minus 5 bar. Then you can get the 1.01325 bar. C is the answer. Next question, friends. Which of the following manometers has the highest sensitivity? U-tube manometer, inclined U-tube, U-tube manometer mercury, micromanometer with water. D, micromanometer with water. Remember this question. Okay. Micromanometer with the water has the highest sensitivity. Micrometers are the instruments Micromanometers are the instruments that work on the manometer principle but are specially designed to minimize the capillary effects and meniscus readings error. A micromanometer is described for the measurement of the differential pressure greater than the 10 to the minus 4 in of the water with the tolerable accuracy. Next question, friends. Pressure of 80 kilopascal is equivalent to a head in the meter of the carbon tetrachloride of relatively density is 1.59 of the value. We know the pressure equal to rho GH, where pressure is 80 kilopascal, so 80 into 10 to the 3 Pascal, and the rho equal to 159 into 090 because it's multiplied by 1000. Okay, and rho is equal to 1590 into 9.81 into h, and the here is p equal to 80 into 10 to the 3. If you solve this equation, you can get the answer easily. Here is the solution. After solving this question, you can get the 5.3 meter. Next question, friends. Formula for the finding the difference of the pressure in the two pipes at the same level carry different liquids of the specific gravities S1 and the S2. Using the differential manometer having the mercury of the specific gravity S3. Okay, this is the A, H1 minus HB equal to H2 S2, H3 S3, H minus S1. Here is the diagram and the explanation. Next question, friends. A manometer is used to measure low pressure, moderate pressure, high pressure, atmospheric pressure. Manometer used for the high pressure. A manometer is used for the measure the high pressure and the negative pressure also. Piezometer is not used to the measure the negative pressure or the very high pressure. Predict the pressure in kilopascal at and the elevation of the 200 meter in isothermal atmosphere, assuming the T equal to 20 degrees centigrade and the P atmosphere equal to 100 kilopascal. We know the P equal to rho G into H. Okay, rho G into H and the isothermal atmospheric pressure. assume okay. So you solve the P equal to rho GH equation, you can get the pressure 20.012 kilopascal. This pressure is the gauge pressure. So I find the absolute pressure. Okay. So absolute pressure equal to atmospheric pressure minus gauge pressure. So 100 minus 20.012 is 79.98 kilopascal, or the 79 kilopascal. Next question. The difference in the pressure head the measured by a mercury water differential manometer for a 20 centimeter difference of the mercury level will be. What is the difference in pressure head measured by the mercury water differential manometer 20 centimeter of the 20 centimeter difference of mercury level? P1 equal to rho g h1, P2 equal to rho g h2, rho g2. Okay. Mercury water differential manometer for the 20 centimeter, what is the mercury level? Okay. By solving this easily, you can solve the 20 centimeter of the water. It's convert the mercury level. We know the 76 in centimeter is given. So 76 centimeter equal to 76 centimeter equal to centimeter of Hg equal to 10.33 meter, yani 10 to the minus 10 to the 2 centimeter, 10 to the 2 centimeter. Then you can solve by the वैकिक नियम प्रोसेस, वैकिक नियम से सॉल्व कर सकते हो. 1 सेंटीमीटर इक्वल टू डिवाइडेड बाय 10.33 into 10 to the 2 divided by 76, and for 20 centimeter into 20 you can solve this. Then you can get the answer in centimeter. Then you solve the convert this centimeter to meter, or here you solving this centimeter is you put the 0.76 meter, Hg equal to 10.33 meter. Then you can solve this equation, then answer is coming in meter. Sorry friends, here the differential reading differential reading is given. The difference x is given. If x is given, then you put this equation is equal to s hg minus specific gravity of the mercury by the specific gravity of the water minus 1 into x. Next question friends. The pressure head of the fluid is the ratio of the intensity of pressure to. The pressure head of a fluid is the ratio of the intensity of pressure to the specific weight g. So rho g is the specific weight. Let's check the answer. Yes, the pressure head of the fluid is generally the ratio of the intensity of pressure to the specific weight. Next question. Piezometer is used to measure. Piezometer is used to measure the pressure in pipe, channels, etc. Atmospheric pressure, very low pressure, difference of the pressure between 2 points. Piezometer used for the pressure in pipe channels. A piezometer is used to measure the pressure. It is the simplest form of the manometers used for the measuring moderate pressure of the liquid. A differential manometer is used to measure the difference of the pressure between 2 points in a pipe. How is the difference of the pressure head H is measured by the mercury oil differential manometer expresses H equal to X into S specific gravity of the manometer by the specific gravity of the oil. So D is the answer. Next question, inverted differential manometer used or measuring the difference low pressure where the accuracy is the prime consideration, measuring difference of the pressure in two different pipe, measuring small pressure, measuring the negative pressure. Inverted differential manometer used. Measuring the difference low pressure where the accuracy is the prime consideration. Let's check. This is the correct. Uh, Inverted differential manometer is used for the measuring uh, the low pressure where the accuracy is the prime consideration. A manometer by the definition is a device used for the measuring the pressure of the fluid by the balancing it against a predetermined column of the fluid. Types of the manometer: U-tube manometer, differential U-tube manometer, inverted U-tube manometer, and the inclined manometer. A mercury water manometer has the gauge difference of 500 mm. Difference in the elevation of the mineral. What will be the difference in the pressure? X is given elevation difference 0.5. You can put this equation. X is 0.5 and the differential reading. The height of the water column equivalent to the pressure 2 kg a per centimeter square. First, it's convert into Pascal, then solve. 1 kgf equal to 9.81 and 1 centimeter equal to 10 to the power minus 2. So 2 kgf equal to 2 into 9.81 divided by 10 to the power minus 4. Then you can get the pressure in Pascal. Then you apply the P equal to rho gh, where is you determinate this pressure is put here, then the rho g is the 9.81 into 1000. So you can get the h, the height of the pressure of the water column, height of water on the water column, 20 meters. Next question, for the flow through a horizontal pipe, the pressure gradient delta P by delta X of the flow direction is positive 1, 0, negative. Flow direction is negative. Let's check. For the flow through a horizontal pipe, the pressure gradient delta P by delta X is the flow direction is negative because the energy is losses. And pressure flow, fluid flow, high pressure to low pressure. Next question, differential pressure head measured by the mercury of the oil differential manometer equivalent to the 60 mm of the difference of the mercury levels nearby. Equivalent mercury levels 0.6, x here the put 0.6, and the density of the manometer is 13600 and the oil is 900 minus 1, and you could get the 8.47 meter of the oil. Next question, the differential manometer connected to a pitot-static tube used for the measuring the fluid velocity gives. The differential manometer connected to pitot-static tube, okay, used for the measuring fluid velocity gives the static pressure, dynamic total pressure, dynamic pressure, difference between the total pressure and the dynamic pressure. I think these are the total pressure and the dynamic dynamic pressure is the answer. Here the explanation. The differential manometer connected to a petrostatic tube for the measuring fluid velocity gives the dynamic pressure. Dynamic pressure equal to static pressure minus stagnation pressure minus static pressure. The end of the pitot tube measuring the stagnation pressure and the piezometric tube measuring the static pressure may be connected to stable differential manometer for the determination of the flow velocity and hence the flow rate. The pitot tube, also known as the pitot prop, okay, is a flow measurement device used to measure fluid flow velocity. Pitot widely used to determine the airspeed of and the aircraft water speed of the boat and the measure liquid air and the gases flow velocity in the certain industrial application. Friends, I am a student of the mechanical engineering. I also preparing for the SSC JE. And so I also discussed this first time of the previous year question of this book. So if I wrong have any questions, please forgive me. ओके, और मेरे साथ प्रिपरेशन करने के लिए प्लीज़ चैनल पे जुड़ जाइए। ओके, चैनल को सब्सक्राइब कर लीजिए एंड डेली बेसिस में प्रीवियस ईयर क्वेश्चन डिस्कस करने के लिए मेरे लाइव में ज्वाइन होना। ठीक है, next question, and the we already covered the two chapter. This is the third chapter, the hydrostatic force on the surface. Question number 396. The point in the immersed body through which the resultant pressure of the liquid may be taken to act is known as the center of the buoyancy. sorry क्या बोल रहा हूँ मैं, center of the pressure. Center of the pressure. What is the center of the center of the pressure is the point where the total sum of the pressure fluid act on a body, causing a force act through that point. The center of the pressure is always below the center of the gravity of the pressure. When the plane is the horizontal position, the center of the gravity and the center of the pressure of the surface are at the same point. Okay, this is the formula of the center of the pressure. Distance h bar is the distance the free surface to the pressure center of pressure. Next question, the center of the pressure and immersed surface at the center of the gravity, above the center of the gravity, below the center of the gravity, depends on the viscosity, generally below the center of the gravity. Yes. Next question, the rate of increase of the pressure in a vertical downward direction is equal to which of the following properties of a liquid? Density, specific gravity, specific volume, specific weight. The rate of increase in of the pressure direction is equal to which of the following parameter? We know the hydrostatic equal to rho g a h bar. Rho g specific weight. This is the answer. Let's check. Hydrostatic fluid, the rate of the increase of the pressure in the vertical direction is equal to the specific weight of the liquid. Next question, the hydrostatic, what would be the summation of the net force acting on the fluid element? 0, 1, less than 0, greater than 0. In the hydrostatic, the what would be the summation of the net force? Net force is 0. Let's check. In hydrostatic, the summation of the net force acting on a fluid element would be 0 in hydrostatic fluid, and any force developed is only due to the normal stresses, pressure, no sharing forces acting on it. For and the element of the fluid at rest, the element will be the equilibrium. The sum of the components of these forces or any direction will be 0. The sum of the movement of the forces on the element about any point must be also zero, must also be zero. The horizontal components of a force on a curved surface is equal to horizontal force of the components, product of the pressure at its centroid and the area weight of the liquid retained by the curved area, force on the vertical projection of the curved surface, height of the liquid vertical above the curved surface, force on the vertical projection of the curved surface. Let's check. The horizontal component of the force on a curved surface is equal to the force on the vertical projection of the curved surface. Okay, this is the rho g integration h dA cos theta. For the y direction, this is for the x direction, and the net force equal to root over fx square, my horizontal and the vertical square, force square. Friends, thank you so much for the watching this video. And if you new my channel, please subscribe and on the notification to get the notify in the new classes and joining with me. Thank you so much.